Welcome back, Padres. Hope you guys are staying dry. I'm recording this Thursday. It has been raining, raining, raining. I got my rain hat on, and hope you guys are doing okay. We are going to spend part of this week talking about work, and then next week we have our test. Because next week is the last week before our February week off. So we're going to wrap up this unit before then. So, and there will be an ed puzzle kind of going over what's on the test and all that stuff. But for now, let's talk about work, the last new concept. So, work is W. Work is applying a force over a distance. So, you are doing work in physics terms if you're applying a force over a distance. The units are joules, just like energy. And the math equation for work is force times distance. So, pretty simple. All right. Notice if you're not moving, you are doing zero work. This is because if the distance traveled is zero, you are doing no work. In the past, I have done a demonstration where I've had a student come to the front of the class and I fill two large jugs of water and I have them like straighten their arms out to both sides and try to hold those jugs outstretched. And for that student, it definitely feels like they're doing work. But there is no work being done because there's no distance. Now, there was work being done to lift the jugs. Once the jugs are lifted to their height, and then they're no longer doing work. So there is a force being applied, but there's no distance being traveled. All right, let's look at an easy example. How much work is done if you apply 6 newtons of force to lift a jug of water a distance of 3 meters? We have 6 newtons, 3 meters, 18 joules. Very simple, simple, simple. Example 2. How much work is done if you apply 6 newtons of force to hold a brick stationary over your head? What do you think? Put it in the ed puzzle. What do you think? The answer is 0 because no distance is covered. Once again, you have to do work to lift it there, but once you're holding it stationary, no distance, no work. You're no longer doing work at that point. Tip. To find the work, the force and distance can only be multiplied if they are in the same direction. So keep that in mind, especially for honor students. They need to be in the same direction. To show you an example of this, here is a quick honors problem. How much work is done if you apply 6 newtons of force to pull the box 3 meters if there's a 60-degree angle? So we know there's 6 newtons and 3 meters, but it's getting pulled along the x-axis. So we need the force in the x direction, which would be our cosine. And if you do 6 cosine 60, you'd get 3. And so the work would be force times distance, but the force has to be the same direction as the distance. It's kind of like, it goes back to our vectors. If you have two vectors like this, you can't, and this one's 4 and this one's 5, you can't add 4 plus 5. You have to do the x parts and the y parts and all that stuff. Same with this. You have to do you can only add them together if they're like this. You have to be going the same direction. All right, here's some practice. See what you get. What do you get for number 1? And what do you get for number 2? And what do you get for number 3? And for honors, what do you get for that one? All right. All right. My computer was freaking out a little bit, but I think it's okay. So, at the beginning of this unit, I said we are going to put a hold on defining what energy is. Now, we're finally going to reveal it at the very end. Energy is the ability to do work. Some of you did say this at the very beginning. Energy is the ability to do work. So, what does that mean? Energy has the ability to apply a force over a distance. So, if you compress a spring, that spring wants to push something over a distance. If we're talking about nuclear power, a nuclear power plant, the energy released in a nuclear power plant, that energy released has the ability to push something a distance. If you have a moving car has kinetic energy that has the ability to push something over a distance. Thermal energy is heat, right? Heat has the ability to push something over a distance. How? That's how engines work, right? You have a bunch of heat, and then actually it's kind of ignited, but you can have heat engines that work. So heat engines, basically because of the temperature difference, there's a higher pressure, which can push a piston or a cylinder. So all of those are the ability to push something a distance. And so when we think about all these different types of energy and how they're all really different from each other, that's true, but they all have that same ability. Okay, let's think about it. We have two charges here. They are both protons. We know that opposites attract and like charges repel. And if we looked at the electric field produced by two positive objects, the electric field would look like this. And you can kind of see why these two objects would want to repel each other. So my first question is a force needed to hold this left one in place? What do you think? Answer that. The answer is yes. So you'd have to hold it there. If you didn't hold it, it'd get pushed away, right? Are you doing any work to hold it there? The answer is no. No work is needed because it is stationary. No distance means no work. If you push this charge to the right, are you doing work? The answer is yes. You're doing work because you're pushing over a distance. And finally, what would you say is also increasing as you push this positive object to the right? You're increasing the energy. The closer you get it, the more it wants to push apart. It's kind of like a spring. The more you push it, the stronger that force is that's trying to repel it. So you're increasing the stored or potential energy between those two particles. So as you do work, you're increasing the energy. Okay, hold that thought. Let's look at this real quick. This is going to kind of tie everything together. This is our last slide. How much work is needed to lift a 2 kilogram chihuahua a distance of 4 meters? So if I lifted a chihuahua up, the work would be force times distance. Force is not kilograms. Distance is meters. So distance is 4, but what's the force? What force do we have to lift it? If it has a mass of 2, gravity's pushing down with F equals ma. So the mass is 2. Gravity's pushing down 10. So that'd be 20 going down. So if you want to push it, you have to push it up 20. So if you push it up 20, 4 meters, that answer would be 80, which I did not write here. So this would be 80 joules to lift that Chihuahua. Okay. I'll put a little note there so that you can kind of see the math that I just did mentally. What is the GPE of the Chihuahua at a height of 4 meters? For GPE, we need mass times gravity times height. Oh my gosh, it's also 80. So where does this potential energy come from? The potential energy comes from the work. So if you lift the Chihuahua, it takes 80 joules of work to lift the Chihuahua. Now that Chihuahua is in place, you're no longer doing work. What happened to that 80 joules? It's stored there as potential energy. And if we release the Chihuahua and we drop it, the kinetic energy right before it hits the ground is 80 joules again. It's kind of like a spring. If we do work to compress a spring, force times distance, compress the spring, we did work to compress it, that energy is now stored as potential energy inside the spring. So you can kind of say that work is needed to create energy, but really work is in joules, so really work is kind of a different type of energy. And I think that's it. So I just kind of want to get the point across really well because it's a very central idea here. When we say something has potential energy, but energy is not created and not destroyed, not created, where did that energy come from? It comes from the work done. So you have to do work on something to give it that energy. Awesome. Like I said, we will have a test. There'll be a separate video out later this week going over what's on the test. And test next week. All right. I will see you guys soon.